By the way, that's a Strudenoff impact mill there. It's a very good piece of equipment for ease of maintenance and ease of using, replacing and rerunning your hammers on there, which is one of the major problems with impact mills. You keep running up, you keep wearing out your hammers. You can replace all that very easily with that. And the reason we have it set up like that is we're higher so that we can feed out of the bottom, which is the bottom is this. It actually is your screen material comes out here at the bottom. It will run off of there right onto the table, replacing the impact, the trommel there. Trommels are very good for if the ore is already ground or you're running a placer operation or something like that. But if you do have to grind Strudenoff, it screens and then grinds it all up, and it also cuts down no dust. And I really like the no dust. Actually, everybody likes the no dust. If you do have mercury in your ore, you should be running with gloves on at all times. Mercury is not good for you. Now you can see we're getting towards the end. We're starting to run out of ore here, and our line has showed up again. As soon as we're not feeding, as long as now we're down to no more dirt feeding in there, it's now running more tails off the table, so that's bringing that line down. Now, the question I'm always asked is there any more gold on the table when I get done with the concentrates? And yes, there is. There's going to be gold in here, there's going to be a little gold in here, and there might be even a little gold in here. But in production, I'm not trying to get the 1/10 of a gram out of this little amount when I've just run 10 tons of material. What I'm going to do is just open this up, take it, put it in another bucket, throw it back on the table, and any gold that is still on the table will be back up here on our top line. Then I put it back in a bucket next time, and then tomorrow when I start all over again, I just throw that on the table first. And I still have my gold, and I'm not working long hours trying to get that little last half a gram or so out of there. Now that we've got our concentrate in our bucket in the back here, what we're going to do is I'm going to raise the table, the back end of the table back up, throw it back on, and get our gold line. And then we're going to have a gold line that we can vacuum off and weigh and fire, hopefully. Well, hi, Junie. Now, same thing, what we're going to do is now I'm going to raise the back of this table up with the leg adjustments. Here's our line right now. I'm going to move this line all the way back up to here, up to the front. we've moved our line back up to the front. Now we just take this off, move this back to the back. The reason we move it back to the back when we're running small amounts is because it makes it easier for us to get to the line and look at it. That is the only reason. The reason that this is where it would normally be when you're running production. Now, you can hear how hard it's hitting. That's we had set up for production. A lot more weight on the table. And what we're going to do is just turn it down a little bit, so it's not banging so hard. Gentle. We like gentle. As long as it keeps this bed fluid, that's all we want. We're not trying to pound the gold up to the top. We're just getting it to go up there with gentleness. Can you see this line real well? Good. Okay, now I'm going to feed in the concentrates that we just made. Pour some of this water off. Got it? So you can see the amount that we just made out of that 2 buckets, which is plenty. Now once again, you can see we're back to our black line. Now, you also get a wash tube just like we have back here that goes on this tray, and it's for when you're running small samples to keep water running in here, so you're always in a slurry situation. When you're running production, you have your water flow either out of your trommel or out of your impact or out of your ball mill, and that's the flow that you're going to use. Now I'm going to go ahead and take this trough off so that we can see that real well. Just shut it off, took that popper off of there so that we could see this better. Now you can see I put my finger in there and it goes right down to the table without me pushing on it. That's what we want. If you're on this ore and you're pushing like this and you're not touching the bottom, this is packed. If it's packed, the gold is not going to come out from underneath it. Now, from over there, I don't know if you can see it, but we have a nice gold line right here. And we've got some big pieces of gold here too. Good. This ore was assayed running about 1 ounce at a ton. So if everything went right here, we should have about, well, less than a gram of gold out of that 100 pounds that we just ran. Which might be low because it looks like we might have more than that, which is good. Okay, now what we're going to do is we're going to vacuum this off so that we can pan it and take a look at it. I'm going to go get the vacuum cleaner. And we do that when we're running small samples. When you're running large samples, actually you'll be seeing an Alaskan operation, and they have a lot of gold. They don't need to worry about what we're looking at here. But in a when you're doing small testing, what you want to do is you want to take all of this blacks off of here, along with your gold. And then what you would do is normally you do a fire assay and fire it. In production, the same thing is going to happen, except you're going to have a whole lot more gold. Now, with a wet and dry vacuum cleaner that we have, we can either take 90% of the gold off the table as very, very clean gold, and then leave about 10% in this black sands here and just fire it. It just depends on what you want to do or how much you're actually running. In a commercial operation, if it's 10% by weight gold, it is a sellable product. In other words, you can either sell it or go right into a smelter and make a dory bar out of it. And this is what I was talking about. See, we have a little bit of black sand loss right here. And that's what we're going to look for. We don't want any down in here. And that's what you would look for. What you do is you'd actually take each one of these off separately, see how it was, and test them to see how much gold was lost, so that you could either regulate how fast you were feeding your ore, if you're running too fast or too little. Take that top line off of there. You can also check to see if you have any underneath there by just simply moving this ore back up and letting it do its thing. And you can see we brought up a little bit more. Do that a couple of times after that. You just throw it in a bucket, and tomorrow when you start up again, you just throw that bucket on the ore on the table first, and you've got your gold again. And you can see we didn't have very much left underneath there, even with just trying to get it out from underneath there. That we were talking about, this is the hydraulic pump. As you can see, we got our holes, and the ore is down below the top of the bar here. What it has to do is it actually pumps itself up over this, and that keeps any float material on the table, so you never have any float running off your table. And that's what the two primary reasons for that is, to make the ore run faster and to keep float material on the table. Is we shut everything down, and you can see your gold line right here. Okay, that's the yellow. Now you'll also see that you've got your blacks, which is probably magnetic, or if you were running through a ball mill or anything like that, impact mill, this is your iron is up in here. Your black sand is in here, and that's what we're looking for. As you can see, that it's really distinct. I mean, there's actually a ridge from this material here up to this sand material, and this is your tails. Now we'll vacuum all this off and then repan it so that we can see and weigh this amount of gold, what we got here. But in production, what we do is this would all be in one bucket, and we just throw it in a smelter and smelt the whole thing. And as actually, you can see how you have ridges here, these ridges right here. Okay, that's where the ripples, the waves actually stopped, and that's what actually it causes that. And that's what we're working at, is to make them waves do that so that we have the material fall to the tabletop, and then it moves itself back. We're in the office, in the lab. These are the concentrates that we made out there on the table. What I want to do first is I want to screen it, take the magnetics out, pan it, and here we go. Now I'm just going to screen this. The reason I do this is to get rid of the larger pieces of material that came up with the concentrates. If they're big pieces of gold, you can see them really easily, so it's not a problem with that. But it makes it a lot easier to pan so that you can get your fine material out of here real easily. You can either get yourself a very expensive screen, or you can go to the hardware store or grocery store and pick up one of these little nylon screens that they use in the kitchen, which lasts for just about ever, and just the right size. All right. See, that's the larger material that we got out of there. Now just put this screen material back in our pan here. Wash it into the pan. And we're going to screen it. I'm going to take the magnetics out just because we have any. It's easier getting them out now. Now you can see the magnetics there. And if you just threw that away just like that, what you have is you just got a bunch of gold in there. What you got to do is wash that good. What you have is a natural affinity for magnetics and gold. Specific gravity is up there. Magnetics are... gold is not magnetic, but it just likes to be with it. And it will stick to it with surface tension, water surface tension. So what you got to do is, when you do this, is make sure that that gold doesn't stick. There's your gold, your magnetics. See, now we almost just got rid of all of them there. All right. Now the way we pan this is we're looking for the fine gold, and we want to get rid of the larger stuff. So we get our gold cons down in the pan like that, and then we're going to put it into the surface of the water and let the water run in, cause swirls, move the pan out from underneath the swirl. You can see how the black is lined up on the top of the surface again, and that's what happens to the gold. Just sits underneath the surface, the real fine stuff. So what we do is we knock it back down into there. Do the same thing. And that gives that fine gold a chance to settle into that sand. And see, now we worked real hard all day long trying to do this. Don't get in a hurry to get this done. And we do this for testing. We really wouldn't do this if we were going to smelt this. If you ran a ore all day long, this is going to be your high-grade concentrates. Just dry them out, throw them in the furnace, and smelt them. Now, the gold that you get out of the ground is usually running somewhere between 76 and maybe 85% pure gold, which means if you got an ounce of raw gold that you got out of the ground, it means only about 75% of that ounce is really pure gold. On the off chance it may be 85%. So when you smelt it, what you're going to do is get rid of more of the trash, and a lot of it's going to be copper. And if you have silver, the silver is going to be with that dory bar. Now we're down to just a little bit here, and then what we're going to do is we're going to act just like we do on a table. We're going to gently knock it up, roll the pan around, and as you can see, there's my gold line. This band up here, and right here you see this dark stuff. That's not gold. There may be some gold in there, but that isn't your gold. Your gold runs from way down here all the way over to here. Now we'll look under the microscope. Now you can also see how fine this gold is, and that's the fineness that we're looking for. The bigger stuff is over here, the finer material is over here. So what we're going to do is look at this underneath the microscope so you can see the individual particles. There's some nice gold in it. That mesh size there, that you're looking at 6, 7 microns, 10, 12 at the most. Mesh size wise, you couldn't get it through a screen. 1,000, 1,500, something like that. But when it gets that small, it's not worth talking about mesh size. Dust particles, what you're looking at. Mesh material there, which is about 150 microns or so. So you're looking at 10 times the size of the pieces that you were just looking at. And that's the material right there that your normal gravity separation material, equipment will separate. So we catch that, and we also catch all the fine material. And the fine material, as you noticed in the pan, was a lot more there than there is in this big stuff. And this is big as far as we're concerned. 100 mesh is easy to catch. And that's the end phenomenon of what we've been doing all day long. We want to see that yellow stuff. This is the M4. This is your lab unit. This one runs off of 12-volt DC. You can put it on a trailer, run it off your battery of your car. I'm going to show you how to run it. Basically, you got 12 volts. I'm running off of a battery charger here. And as you can see, it doesn't turn on right away. What you have to do is turn up the voltage. Running way too fast. Slow it down. Right in there is where you want it. Here's your water flow. This is going to be the one that we use for our ore. This is the one that just keep it clean so we can see what we're doing. What I'm going to do is feed a little bit of ore in here. Now our line should be right in here. Get your table wet. See how we have our riffles here? Okay, we're going to put some dirt in here. This obviously will not run as much as this, the M7. It's for doing 2 and 3, maybe 5 pound ore samples. You can see we've got the same thing as we had on the N7. Here's our black sands. And here's our gold line already. You can see I'm running it real slow. It's hardly hitting very much at all, but we still have our black line, we have our tails, and here's our gold. Can you see that gold line? And that's as simple as it gets. Now, I'm going to show you what happens when you turn it up too fast. The same thing will happen to this table and that table over there. If you start hitting too hard, see how your gold is disappearing? What it's doing is it's forcing the gold into this bar, and that isn't what we want. So we turn it back down. And there's our gold line again, going right back up. Now you can see the same thing. We got this bolted down to a heavy table, but you can see it still wants to shake. So once you get it into a rhythm, that rhythm is what it likes. And once it gets into that rhythm, it will move things. So the better you have it bolted to the ground, the better. Gold right out from underneath the black sands. And that's what these tables are all about, getting that gold out of that black sand in a very short amount of time. This is a 5 to 8 ton an hour table. What we're going to do is just turn it on and let it run just a minute. I'm not going to run any dirt on it. I'm going to show you the adjustments to it. The reason I have it set up right now, as you can see, I'm running my hydraulics over here off of a gasoline engine, which you can do, or what comes with a table normally is an electric motor. So if you're in a remote area and you needed to run off of a gasoline motor, you can without going to a generator. Hydraulic lines. This is your this unit right here is what controls how fast or slow this goes. And we'll just go slow here. I can see how slow I can make it go. This will run all the way up to about 500 RPMs, which is too fast. Now, a few things that we have here. There's a hydraulic motor underneath here that actually runs an eccentric that is controlled with this thing right here. What this part right here is for is to actually adjust the tabletop inside of the frame. You only adjust that when it's off, and you have to do that by hand so that you just turn it so that you do not move the table so far back that actually contacts the linear bearings that are underneath here with the shaft holders. If it does, it breaks something. Normally the most expensive part, which is the bearing. These two units right here are for actually the bump, and that is actually controlled on both sides so that once it's level in this direction, If it's off a little bit, you can actually adjust the bump so that you can get the ore to flow evenly and come up the table evenly on both sides. There's rubber pads in between the two plates, and that's what this adjustment's for. Okay, this is the feed tube. This is actually what you pump your fluid, your ore slurry into, and then it's got notches on the bottom that actually feed it all the way across the table. Now, moving that out of the way, you can see this is our riffle pump area that we were talking about was plastic on the other one. It's actually two metal tube rods here. The ore actually has to go underneath here and over the next one. So here's your float again. It cannot get past your float. Your float gold will not go off the table. This is just set up in a general area. If you actually move this riffle bar towards this end, which is your concentrate end, you will make more concentrates. In other words, out of 5 tons, you can make 500 pounds, or you make 5,000 pounds. You move it up this way, you're getting to the 5,000. You move it down this way, you get to the 500. And then, like I said, these are all bolted down, and it's so that this piece is flat and level all the way across the table. Now, as you can see here, this matting is installed on the M10. This is where your V's come from. You got your fine material down here in the V. Any large material cannot get to it, so that you don't have a problem with oversized material in your ore feed, so that your fine gold is still coming out the back. And in this case, so this piece right here is your discharge. This one right here. This is your discharge. This is your concentrate discharge right there. Now, you can see I just have it rolling back and forth right now. I don't have very much on it. And you can see that the trailer that I have on it is only about, 15,000 pounds. Now, to give you an idea what happens if you don't have this down real tight, as you can see, the trailer is moving. It actually takes about, if you were going to run 8 tons an hour on this table, you need to be looking at about 8 to 12 tons of concrete underneath it to hold it down. The more concrete, the better. Because you have an awful lot of force here moving back and forth. And once it gets into the rhythm, that rhythm is what we work very hard to get, so that we have this smooth action back and forth. So there is no bouncing. So what we have is that whole momentum moving back and forth and stopping when it gets to this end up here. Well, if it's not bolted down to the ground sufficiently, it will move something. And you don't want it to take the table that you want moving. That is just about all on the M10. Gives you an idea what it's for, how big it is. Like I said, you're going to be running somewhere between 2 and 3 tons an hour minimum on this table just to make it work right. 5 to 8 tons an hour is what it's rated at. You would actually take this material off the table, run it right directly onto an M7, so you could take basically 2,000 pounds of material off this table as a primary concentrate right onto an M7 in an hour, so that you're running from, let's say if you were running at 8 tons an hour and you were pulling out 2,000 pounds an hour, that's only a 4-to-1 concentrate, right? No, yeah, what? 8-to-1 concentrate, I'm sorry. It's an 8-to-1 concentrate, which runs right onto an M7, which runs the same hourly rate. So what you have is you're running 8 tons an hour right here. You're running right onto an M7. You are now making a concentrate that maybe is 20 pounds out of 8 tons. Very simple, very quickly. Thank you.